In this lecture, we are going to discuss about scheduling criteria. So before we start studying about the different scheduling algorithms we need to know about the different scheduling criterias based on which we can compare different scheduling algorithms. So when we have different scheduling algorithms, on what basis are we going to compare them? Or on what basis are we going to decide or find out the efficiency of a particular algorithm? So we need to have certain criterias based on which we can decide these factors. So we will be seeing what are the different scheduling criterias that we have in this lecture. So these are the 5 scheduling criterias that we are going to discuss. And this criterias will help us to determine the efficiency of a particular scheduling algorithm. So first of all, we have CPU utilization, then we have throughput, then we have turnaround time, then we have waiting time, and then response time. So these terms may seem new to you, or it may be familiar to you, but what we are going to do is we are going to analyze these terms one by one. We are going to see what they mean, and we will see how they are described in terms of scheduling criteria. So let's take these terms one by one and see what they mean. So the first one is CPU utilization. So it says here, we want to keep the CPU as busy as possible. Conceptually, CPU utilization can range from 0 to 100%. In a real system, it would range from 40% for a likely lower system to 90% for a heavily used system. So basically, what this CPU utilization means is how much the CPU is utilized. So when we have started discussing about CPU scheduling itself, we said that we want to keep the CPU as busy as possible. So that is what we are seeing here. We want to keep the CPU as busy as possible. So when we say this, what we mean is that when the CPU is busy, that means some process is being executed. That means the CPU is doing some work. So the more the CPU is busy, that means the more the work is done, or the more processes are being executed. So that is what we mean by CPU utilization. So we want to make a very efficient utilization of our CPU. We don't want our CPU to remain idle. We want to see that as much as possible the CPU is being utilized whenever it can be. So we want to keep the CPU busy as much as possible. So CPU utilization conceptually can range from 0 to 100%. But in a real system, the range should be between 40 and 90%. That means in a lightly loaded system, it should at least be 40%. And in a heavily loaded system, it can range up to 90%. So within this range, we want the CPU to be busy. That means it has to be utilized within this range. So basically, what you have to remember is we want to keep the CPU as busy as possible. So that is what we mean by CPU utilization. So coming to the next point, we have throughput. Now this may be a new term to some of you, or some of you may already know this. So let us see what is the meaning of this throughput. So if the CPU is busy executing processes, then work is being done. One measure of work is a number of processes that are completed per unit time, called triplet. So throughput is basically a measure of the work done by the CPU. So we know that the CPU will be busy executing processes, and when it is busy executing processes, there is a good CPU utilization. And when there is a good CPU utilization, then work is being done. Now when work is being done, how do we measure that work? So one measure is the number of processes that are completed per unit time. So per unit time, how many processes are completed? That is what we call throughput. So this is a criteria for scheduling. We can see the measure of work done by the CPU by calculating the throughput, which is the number of processes that are completed per unit time. Now the next criteria that we have is turnaround time. Now let us see what do we mean by turnaround time. So from the point of view of a particular process, the important criterion is how long it takes to execute that process. The interval from the time of submission of a process to the time of completion is the turnaround time. So turnaround time is a sum of periods spent waiting to get into memory, waiting in the ready queue, executing on the CPU, and doing input-output operations. So turnaround time. What we mean by this is, we are trying to see this in the view of a process. So when we talked about throughput, we were talking in terms of CPU. That means how much work is done by the CPU per unit time. How many processes are executed by the CPU per unit time was the throughput. We were talking in terms of the CPU. But if we are seeing it from the point of view of a particular process, then we need to look at the turnaround time. So turnaround time, it is the interval from the time of submission of a process to the time of completion of the process. So when a process is submitted for execution and the time it takes to be completely executed. That is what we mean by turnaround time. So when a process is ready, or when a process is created, and when it's ready for execution, we know that a process does not just get the CPU and complete his execution in one go. There are different states that a process goes through, which we have already discussed. So the turnaround time will include all those states: the time the process is ready, and the time the CPU is allocated to it, and the time it executing the CPU. And then there may be different scenarios where it may have to wait for I/O, or it may have to wait to get into the memory, and so on, which we have already discussed. So all this time is taken into account, and the total time that a particular process takes to complete, from the time it is submitted until it is completed, is known as the turnaround time. So turnaround time is a criterion that we have, in which we are seeing from the point of view of a particular process. So that was another scheduling criteria that we have. Now let's go to the next one. So the next criteria that we have is waiting time. The CPU scheduling algorithm does not affect the amount of time during which a process executes or does I/O. It affects only the amount of time that a process spends waiting in the ready queue. So waiting time is the sum of periods spent waiting in the ready queue. So when we talked about the different states of processes, we know that a process can have different states, like the ready state, or when it is in the executing state, or when it is in the waiting state. So waiting state is the time when the process is either waiting for the CPU, or when it is waiting for some input-output operation to be complete. So that is the waiting time of a particular process. Now, what this actually means here is that the CPU scheduling algorithm does not affect the amount of time during which a process executes or does I/O. Now, what does this sentence mean? It is very important when we talk about CPU scheduling. What does scheduling do? Scheduling means the scheduler is assigning the CPU to different processes. So once a process gets the CPU, the time it executes in the CPU, or the time it takes in performing input-output operation, has not depend upon the scheduler. The scheduler has nothing to do with that. Time a process will spend in the CPU, that means using the CPU or performing I/O, will depend upon the process, or how big the process is, or what kind of process is. But what the scheduler is concerned is how fast or how frequently can I assign the CPU to a particular process. So the waiting time is what we will take into account at this moment. So if a process is spending a lot of time in the waiting state, waiting to get the CPU, and if the scheduler is not able to assign the CPU that process, then it will end up waiting for a lot of time. And then we can say that that algorithm is not a very efficient one, because that particular process is starving for the CPU. It is not getting the CPU, so there is a lot of time that it has to spend in waiting. So waiting time is the sum of period spent waiting in the ready queue. So the scheduler must make sure that this waiting time is reduced for every processes. So this is again a very important criterion based on which scheduling algorithms efficiency can be seen. So that is the waiting time. Now coming to the last one, we have response time. So in an interactive system, turnaround time may not be the best criterion often. A process can produce some output fairly early and can continue computing new results while previous results are being output to the user. Thus another measure is the time from the submission of request until the first response is produced. This measure, called the response time, is the time it takes to start responding, not the time it takes to output the response. The turnaround time is generally limited by the speed of the output device. So when we discuss about turnaround time, we saw that turnaround time is the time that the process takes to complete its and higher completion. That means from the time it is entering into the ready
queue
until end, unless it is
fully completed.
So the time it spends waiting
and ready queue,
waiting to do I/O
and all that,
all those things.
So if you are
having a very powerful
and
interactive system, then turnaround time may
not be the best
criterion to
use
in order to judge a particular algorithm. Because if you are having a fast interactive system, a process can produce some output fairly early and it can continue computing new results while the previous results are being output to the user. It said that
process
was doing a particular task. And what happens? It already completed the task very quickly. And while the output of that task is given to the user, at that time, it could already be doing some other task. That means the process is quick that it already completed the task was doing the output. While it is given to the user, at that time, the process is already doing some other new task. So, in this kind of interactive and fast system, the turnaround time may not be very good criterion to judge the efficiency of an algorithm. So for that, we have this response time. So response time is the time from the submission of a request until the first response is produced. So when a particular task is assigned or when a particular task is going to begin, what is the time it takes to produce the first response? That is the response time, and it is not the time it takes to output the response. So see the difference here. It is the measure of time from the submission of a request until the first response is produced, and it is not the time it takes to output the response. So in order to explain this to take an example, let's say that you have a video file in your system, in your computer. So let's say that you wanted to watch that video, and you double-clicked on that video. Now what happens? Video takes a little bit of time to load. It does not load instantly. It takes like 1 or 2 seconds, or maybe a fraction of a second if you are having a very quick system to load. That means for you to see the output, that means for you to see the video on your screen, it takes a little bit of time. But actually, when you already clicked it, the process already might have run in the background. That means the process is already executed. That means the process says that, okay, open this video and show it to the user. The process is already executed, but it takes a slight delay for you to see that output on your screen. So that is what we're talking about here. We don't want to measure the time it takes to output the response, but we want to see when is the first response produced. Means when you clicked on that video file, what is the time it took for the first response to be produced. So that is what we mean by response time. So as I told you, the turnaround time is generally limited by the speed of the output device. So the speed of the output device. So you are having your computer screen, which is an output device. So if the output device is slow for the video file to load, it may take a little bit of time, but the response is already produced in the background. That means the process is already executed. Saying that, load this. So that is what we mean by this response time. We want to measure the time from the submission of request until the first response is produced. So in interactive and quick system, this is a good criterion to measure the efficiency of an algorithm. So those were the different scheduling criteria that we have, which we have to always keep in mind when we study about the different scheduling algorithms. So I hope this scheduling criteria will clear to you. Thank you for watching, and see you in the next one.